But we wanted to solve a more general problem. We wanted to solve common tangent between an upper Hull Q and an upper Hull P. And so far what we have managed is to find a common tangent from one point Qi to the polygon P. Now the question is, can we do this using a repeated binary search? In other words, now that I know how to find tangents from one point, can't I use this to do binary search on the polygon Q now? In other words, by looking at this, I can say that I need to go to the right to find a common tangent between P and Q. I guess I'm going to spoil this because this is very similar to what we did before, and the answer is yes. So let's say you pick a point Qi on the polygon on the upper Hull Q. You find a common tangent. Then you look at the vertex before and the vertex after. If the before is below and the vertex after is above, the line that the common tangent line or the tangent line, then you need to go to the right. But if you have the other case, let's say this case, so in this case, say this is the common tangent, the point below is above, whereas the point after is below, which again is the opposite of that case. So in that case, I know I need to go to the left. And obviously, what is common tangent? A common tangent is a point, let's say this one. Common tangent is a line where if you pick a point Qi and you draw a tangent to point P, both before and the after vertices of Q are below the common tangent. If you find such a line, then you have found the common tangent between P and Q. So this is a binary search on polygon Q, right? So we start with the middle point of Q, and then we go either left or right. At each step, we need to do another binary search. So we need log n steps of binary search. And since every binary search can take at most log n time, it means that between two polygonal chains of total size n, I can find the common tangent in log squared time, which is obviously much faster than log n time. I mean, it doesn't make any difference for this particular algorithm, but it's a more intelligent solution. And there's actually a smarter way of making a little bit of progress at every step. So the problem with this approach is that we cannot, we have to do, if we want to find the common tangent, we have to spend the log n time. And then it looks like we need to repeat this log n time again. So therefore the log squared seems unavoidable. But with a more careful analysis, if you just have 2 points P and Q, if you can tell at least for one of them which way to go, then you can make not as much progress as this, but if you can make a constant factor progress, then you could show that this only takes log n time. So what I'm trying to say is that even though I'm not going to present the detail, is that with a more careful approach, you can improve this to log n times. In other words, you can find the common tangents between two upper hulls in log n time, which obviously is optimal. At least when we are considering algorithms that use predicates.